Okay, now I'm recording. Sorry about that. So again, we're talking about the memory and all the different data structures we're creating. So this class is called Data Structures. It's probably the third programming course you take, maybe the second. It depends on if you're new to the to WISE or older. But in any case, a data structure is how we're going to organize the data that we have to make it easier to process. Okay, and what we need to do with that data and how we need to access it will in large part depend on which data structures that we use. Okay. So again, this is the memory that you get, let's say on our server's a Linux server. When it pops up our process, it's going to assign this much memory to us. Okay. And there's a set amount. I don't know. We'd have to look it up. We could figure it out. Okay. So again, each of these boxes, I'm assuming, is one integer or 4 bytes long. So when we declare a new integer, okay, an integer array, wherever it's at in memory, and again, the heap loads, this is the on-demand memory during the execution of the process. The stack up here is allocated at the beginning of the process. So if your code has an array in it, then there may be other things there, but let's say that, well, it's somewhere up here in the top here, but we'll say it's first. It's going to save 1, 2, 3, 4, 5. It's going to save enough memory for 5 integers, okay, from this line, okay? All it's really saying here is whatever this address is, okay? So if this address is 100, probably not going to be 100, but if it is, then 100 would be all that we know, okay? So advantages to using arrays, I mean, they're built in, they're fairly straightforward. Other languages have them, okay? They're pretty efficient, and then all we have to keep is one memory address, okay? We just keep that memory address to the first instance where the green box is. And then we can do, that's the 0. That would be A0. This is A plus 1 what? Plus 1, whatever type it is. So plus 4 bytes. If this is 100, this is 104, 108, and so on, okay? So all the process has to keep track of is that very first, just that one memory address, okay? But there are some downsides. One of the downsides we've talked about is that the array doesn't enforce length, okay? So in this case, A4 is where I'm at now. It's legit. A5 is not. But C++ is going to say, yeah, fine, I'll do that. So whatever is stored there, could be another number, could be a string, could be a character, could be anything. Whatever's stored in those next 4 bytes is going to be returned to our process. Okay, we don't have any control over that. If you want to control that, you have to make sure you keep track of the size and all that stuff, which has some overhead, but on a really large array, the overhead may be worth it, okay? The other disadvantage to an array is that we don't have the ability to dynamically allocate the space, okay? We have to know before we ever run the program how big we're going to make it, okay? Unless we do a dynamic array, which we talked about. You can't do a dynamic array. Note that dynamic is going to appear down here in the heap. This is where dynamic things are allocated. And if we do it for whatever size, I mean, we can certainly go in there and allocate the memory there. We still only have to keep track of that first memory address. But still, once we make the size of the array, there's no change in it, okay? Because it marks this spot as free, and it can put something there, and it marks this spot as free, it can put something else there, okay? So what we're talking about today is a standard template library, which is a bunch of routines, a bunch of data structures that we can use in our programs, okay? It's cool, you don't have to roll your own. We're going to get very frustrated this semester, all of us will, in creating our own linked list and all that stuff. So you may ask yourself, why don't we just use what we have, use the standard template library, okay? And the issue is standard template library is so robust that it can be expensive, okay? So the first instance, or the first thing we're going to talk about today is going to be the vector, okay? So a vector is, and it works like an array in many ways, except we don't have to know how many elements it's going to have. We can add on the fly, okay? So let's switch colors here. Let's say we're going to make This green is going to be someone meant to do, but that'll be okay. Let me see. Okay, once I've done that. Okay, so that we had this array, dynamic array, down here in the heap. So now we're creating a vector here. Okay, so it's going to put the first element of the vector right here. Okay, then when we go to the next element, it's going to put it in the next available spot. So let's say that all of this here is used, and the next spot we get is up here. Okay, so that's our second element. Okay, our third element could be up there. Our fourth element could even be back here, depending on the memory usage at the time. Okay, so this has the advantage is that, you know, if you don't have the ability to dynamically say how big the array is going to be or add to it, you have to reserve more than you're ever going to need. Okay, so we've talked about the grading program. If you normally have 30 students, but you could have up to 100, I would have to make this array size 100 and have 100 marked off, okay, which is wasteful of memory. Okay, so we don't have that issue. But the issue we do have, because we can still get to every element of the vector directly, it's called random access. I can go to the third one or the 8th one or the 100th one, okay? I have to have somewhere in memory a map of the address of every one of those elements, okay? So I have to know that this is position 0, and this is at position 1, and that this is at position 2, and that this is position 3, okay? Where here, to go from here to here, I can just say +1, and it goes 4 bytes to the right. It's there, okay? Down here, to go from 1 to 2, again, I have to go look up that information and say, okay, I'm at 1, how do I get to 2? Oh, I got to go over to this address. Okay, so there's not only more time involved, but there's also more overhead to keep track of those lists. Okay, so again, if you want to use a vector, you certainly can. If you need dynamic stuff, it works. Vectors have some built-in functions we're going to talk about. The standard template library has some built-in algorithms, which are nice. So there's less coding that you do. Okay. But there are times when you're in a low memory environment. I think that I'm going to use the kids today phrase. Kids today you've always grown up in an environment where there's plenty of memory. I mean, relatively speaking, when memory is cheap. Okay, so computers have minimum of 4 gigs, sometimes more, often more. Okay, I'm going to sound like an old timer because I am. The first computer I ever programmed on had 16K of memory, not M, K. Okay, that's ridiculously low amounts of memory. So memory mattered. So why does memory matter now? Well, memory matters now because it affects processing time. So if you're in a performance sensitive application such as gaming or such as cryptography or anything like that, then those seconds matter. Okay. The other area that this becomes in super handy, and I wish we were in person and had the ability to do this, is programming on embedded systems or on small devices that are embedded in other things. Your car has a bunch of computers nowadays. Your washing machine has computers. Okay. A class I took at Clemson, working on my PhD there, they gave us little, you know, $20 ATM something chips, little teeny chips. We had to put them on a breadboard. We had to power them up. We had to program on these guys, and they were extremely memory limited. Okay, so we had to really, really be careful with the memory. So if you're working, and there are a lot of people that work in those embedded industries, then memory becomes very important, and you can't be wasteful. Okay, so just as a hint, while we're talking about memory, the next data structure we're going to cover. Well, we mentioned briefly the DQ. We'll get to queues and stacks later. We're going to do our own, but there is a DQ in the standard template library that kind of functions as a queue and a stack. We'll talk about a little bit of that beginning tomorrow before we get into linked list. But linked list are the next thing, okay? And the way linked list works, and we'll give it a new color. Let's say the first one's over here. The linked list kind of tries to deal with this. And again, you don't use standard template library on this. You're going to create your own, okay? In that you're going to store the linked list name. You'll have to create a pointer to this first thing. We'll call it root typically, okay? Then when you create another node, wherever it places it, you have to maintain a link. So this node stores, if it's a one-way linked list, it's going to store the next item in the linked list. Okay, so this one would then store the address of the next one. Okay, and so forth. Okay, so what that means is you have no direct way. So again, if we put this at 1, this is 2. That's hard to see. Sorry, that's 3, and that's 4. Okay, there's no way to get to 4. There's no way to get to 2 for that matter, unless you start at 1. The only thing you know where it's at is 1. Okay. Now you could put your own pointer on each one, but there's no, if you do that, then why not just use a vector? So that's kind of what the linked list does. But what the linked list does, you're maintaining very little extra information, just one address. Okay. And it's very good when you know you're going to be processing things sequentially. So if that's your need. Okay. You can have linked lists that go forward and backwards and double-ended and all kinds of stuff. And we'll get to that starting tomorrow. But that's the basic idea. So are there questions about just this idea of memory and how it gets allocated? And it's going to come up a lot. And this is a very rough idea, but I wanted to give us a little bit of an idea. Okay. So let's now start talking about the standard template library in general. Okay. So with this, again, it's like a toy box we have with lots of different information. Okay. And I think the best way to do this is probably to pop up a whiteboard. So let me do that. Organization is amazing if I ever had it, which I don't usually. Okay. Okay, it's there, then disappeared. That's weird. Let's try it again. Okay, now it's not working. That's strange, or maybe it is. There we go. My internet connection's been a little slow today, which is weird. It's not normally. So if I go away, that'll be why. Okay. So again, we're talking. I can't talk today. The standard template library, or the STL. Okay. And again, this template's important. Template means that we're going to have to, and most times we have to send a data type along with the declaration. So we'll see that in a minute. Okay. So this STL, it's available in nearly every that I know of version of C++. Now, again, if you're on a real microsystem, it probably is not. But on Windows, on the Mac, on Linux, whatever you're programming on, certainly on our system, all these are available. Okay. So the 3 basic parts of the STL are 3 major components. Okay. We have containers. We have iterators. We have algorithms. Okay, so the containers, again, are going to be the data structures containers. I think I had that typed wrong or written out wrong. So containers are going to be the data structures that we're going to create. Okay, we have the iterators, which are going to allow us to move back and forth. To iterate, I assume that you've hit that term before. To iterate, again, is to go through something. Okay, and then the algorithms are going to have things like copy and sort and other kinds of things that we can do. Okay, so the containers are going to get broken up into the following. We have the sequence containers. Okay, also called sequential containers. We have the associative containers. Okay, that's going to be like a map if you've used a map before, an associative array. Okay, and then finally we have the container adapters. Okay, so we're not going to get to associative containers, I don't think. We will get to container adapters in chapter 7 and 8. Okay, so breaking down further the sequence containers. If you have questions along the way, make sure you let me know. the sequence containers, we have the following. Okay, we have a vector, which I mentioned briefly just now. We have a DQ, which I also mentioned, and we have a list. Okay. So this first one, the vector, is logically just like an array. Okay, so it's like an array. Okay, as far as what you can do with it. Okay, so there's not much different there. Okay, I'm going to go ahead and switch over. Show a quick way to switch over to the server, just to give you an idea of what the code here looks like. Okay, so don't worry about anything at all except the very basics. I just want it to show up the code here with correct spacing. Okay, so all of this presupposes that we include the vector class. So to include vector. Okay, so that goes up there if you were including IOStream, all of those happen up there. Okay, and again, just as a review, these don't have semicolons at the end. They're not statements, they're not C++ statements at all. The octothorpe here, the hashtag, the pound sign, whatever you want to call it, indicates that this is a preprocessor directive. Same thing if not defined, which means it happens before the compiler ever sees the code. Okay, and while we're at it, we can go ahead and put in our using in case we run this namespace standard. And again, if you're fuzzy on that, that is a C++ statement, and it just means that if we're going to do a cout, we don't have to do the namespace operator, the std : cout. We just do cout. Okay. Okay, so we've included this, so now we can do something with it. Okay, but again, because it's the standard template library, if we want to create one of these, okay, so let's say we want to create something called int list. Okay, we have to give it a type first. The type is a vector, and we're going to use the angle brackets, int. Okay, that's a vector containing integers. We can do the same thing with floats, with doubles. We can do a vector of strings. Okay, and string, I keep forgetting. I'm also in Java, which I think that becomes a capital S. Okay, so that's how we declare our vectors. Okay, so more generally, it's going to be vector with whatever the element type is, and then whatever the name is. Okay. So when we do this, it's going to create an empty vector. So again, that's going to be an address to a memory location where we're going to start things off. Okay. So other ways we can declare this is at the table 4.1 on page 212. You can create it with another vector. Okay. So I could say vector element type vec list parentheses some other vector name. That would be okay. I could declare it by a size. So I could say here 100 if I wanted to set up a default size. Okay. I can also set up a beginning and ending range if I wanted to on this. Okay. So that's the basics of creating our vector. Okay. And once we have a vector, we have a bunch of options there. So let's just go ahead and go with our basic vector here. And then we'll look at some of the things in table 4.2 on page 213 of my book, at least. Okay. So the first one we typically do is on that next page where we have the various operations. This is actually in 4.3 on page 215, when we're going to add elements to the list. Because right now we don't have anything. Okay. So I could say here int list dot pushback some reason this is like that instead of something else normal. 5. Okay. Now if I'd run that, just make sure we're all on the up and up. Okay. It didn't say anything, but we're good. Okay. So that's just placing something out there. In fact, we can do this a couple times if you want, just to have something to deal with. And again, some people had some questions about Emacs, what I'm doing here. So I'll try to say what I'm doing now. Control A takes me to the beginning of the line. Control K allows me to copy. Control V allows me to paste. Sorry, Control Y, kill, yank. I'm going to do a Control A again to get me back to there, so things stay lined up. Okay. If I happen
question regarding
yes,
those, is there anything that takes you just to the bottom? Because like editing those classes that we had to pull out of the book became a bit of a pain when I had to hold the down button for like a good 30 seconds.
there probably is. I don't remember right off the top of my head. I know that a Control V moves you down, and a Control something else moves you up. I don't know. Look up. You can get like the things I know in Emacs are things I do all the time, but Emacs does everything. So yeah, I would look it up. Google it, and there's little, you can get cheat cards. If this were an in-person class, I would have already handed out cheat cards because they're, if just search Emacs cheat cards, you can get all kinds of stuff. Yeah, there probably is a way. There's I know the Control V does do a page down. So, and something else does a page up, but I don't remember. Okay. So we can just add some elements in here. And again, oh, what I was showing you there is that if you end up pasting something like that, if you hit a tab anywhere on the line, it lines it up for you. Okay, so Emacs does automatic stuff. Again, if you don't like Emacs, that's cool. If you've used VI or Vim before, or you want to do Vim, that works for you, go for it. I've used Emacs for over 20 years, and it's what seems normal to me. And Vim seems really awful because I'm not used to that. If you're really struggling with the editor, that it's not an editor class, so the simplest one to use is Nano. I'll pop up Nano in a minute. Okay.
Okay, so on the Emacs, to answer their question, you might be able to use a almost at a control with the greater than sign, but it's definitely a greater than sign, but it looks like it's saying to use a capital M, whatever that is.
That's meta, so that's the Alt key.
Okay, so it's Alt with the greater than should take you to the end of the buffer.
That's weird, it didn't do that. It could be because I'm going with a Mac keyboard. Yeah, yep. Okay. Yeah, you'll have to play around. We don't use the meta key much, but usually it's an Alt, but mine's got, I'm on a Mac with a weird keyboard, so that may be my issue. But yeah, I assume you just Google that because there's tons of stuff out there. Emacs does everything you want it to do, and you'll learn what you need to. In that case, I just do the Control V and go down page at a time. But yeah, it can be slow on a big program. Okay. So once you have this vector container, you have a whole bunch of things that you can do. Okay. The start being is the vector at. So I could do a cout. Our vec is called int list dot at 2. Okay. And that will just print out whatever's at that position number 2. Okay, which is a 25. Again, because we start with 0. Okay. And we go 0, 1, 2 on the positions. Okay. You can also, if you just wanted to do it this way, like you would on an array, that's okay too. Okay. Okay, same thing. And in the server, I assume that you found this, the up arrow key just does a command, it keeps a command history, so I can keep doing that. So I'm always doing Emacs and then editing and then doing the a.out. Okay. So we can do it either way there. We can also, there's a function for front. It returns the first element of the vector, no matter how big it is. There's one for back. Okay. We can clear. We can erase either a position. We can erase from a beginning and end range. We can insert at positions and various descriptions there. We can do the pushback, in which a copy of, we just did the pushback. Yes. The pop back, that's what you can do. pop back will delete the last element. Okay, which if you're coming backwards, you can do that. You can also resize your vector on the fly. Okay. So those are the basic ideas that we have there. Okay. So some other things we have here. The next part is the iterator to a vector. Okay. So the iterator again is going to be a pointer that we're going to use to move through. Okay. So the class vector contains a type def iterator, which is declared as a public member. Okay. And we do that as follows. Okay. So we could say in our code, we've got our vector list. Before we do anything to it, we could say vector int. Okay, so we're getting the namespace of the vector int iterator. We're going to call it int vec iter for iterator. Okay, so we now have an iterator of type a vector of integers. Okay, note that this iterator does not yet point to int list. Okay,
So it doesn't need the dereferencing operator in the there, correct? It automatically.
yes, it is a memory address. So yeah. Okay, and let's double check it. Make sure we're correct. Make sure the book's correct. Yep. And we didn't do anything different, but yeah. Okay. Just the same way when we're doing an array, we don't have to put the ampersand, even though it is a memory address. Okay. So if you want to set this to some position in our list, so let's go. Let's say we've now entered these guys here. Okay. I could say that my int vec iterator is equal to int list dot begin. Okay. So our vector is going to automatically keep track of the beginning position, the beginning memory location, the end and the ending location. So they're both there. Okay. I could do a for loop in the following way. I could say for my int vec iterator starts at the int list dot begin. Okay, it's going to go as long as the int vec iterator does not equal the int list dot end. Okay, and then got our int vec list at the end. Why does that not? That's odd that there's no plus plus on that. So this is saying, oh, because it's updating. No, that's weird. I'm not sure this works. This may be bad code. This is not the example I typed in earlier today. Let's see. Let's see what we get. I'm just going to see out. We're looking at what's stored at that position. Okay. Yeah, it doesn't like that. I didn't think so. So let's fix that. What it should have, yeah, there should be a plus plus there. I suspected as much. I don't think it matters which side you put the plus plus on. That's not what I wanted. I messed up my order.
So the
Something like that. Oh, I must have called it something different.
so the dot end, it spits out the next address it would store memory at.
The what?
So how would you get the last element in this for loop if it can't be equal to int list dot end? how does it spit out the last thing in the vector?
Does it? Maybe it doesn't. Let's see. Okay, so it doesn't like something. Why does it like that?
Should it be int vector iterator instead of int list?
No, you don't. It's the list that you. That's just a weird example, because in that example, there's no int vec list anywhere. Let's look at example 4.5 actually does work. Let's see what it's got. So we don't confuse ourselves any further. We go from the begin. Okay, so we've got, oh, it is plus plus. It's this, that's what it is. It is it's int vec iter. It's this, it's not this up here. It's this one we're setting the vector to. That's, but it still needs a plus plus. No, it's not. It's got two different things going on there. So let's look at the other example. I have everything together and I'll do a different example and it totally blows up. So in this example, we've got an int list like before. And then we're setting up our list IT, they're calling it, is the vector. Okay, or the iterator. So the iterator is equal to the begin position. We're okay there. As long as that does not equal. Yeah, they're still doing the plus plus on that int. Vec iter. Which I think is what you said, Dylan. Still not happy.
You stuck int vec iter between the pluses.
But I want to do that. Come on. I split the difference. One before, one after. That's what we want. So you go off script, things get funny. So it doesn't like something. Oh. Capitalization issue. You know, you probably see this. When things go wrong, they all go wrong. And then you get irritated or flustered or whatever the combination of those two are, and nothing works. There we go. Okay, and that printed out really ugly, but it did get it out there. It does include the last one though, which is interesting. Let's think about how it doesn't do that. So let's think of a normal for loop. Okay, it's the terminal condition there. It could be and is one passed. Let's look up and. They often do weird things like that in C++. I'm not sure what it defines in. That's my guess, that end is the element past where you have to go. I don't actually see that defined anywhere, which would be super cool if you did, but I'm sure it's there somewhere. But yeah, we'll have to look that up. But I think that must be what's happening. So it's no longer a valid address. Yeah, it does. Oh, here's begin and end. Okay. So the function begin is position of the first element. Function end returns the position of the last element, which is odd. I wonder. Oh, it's because just the way they're doing it here, the plus plus is going to do it before. So it's going to go ahead and do the next one, but that should miss the first one. I don't know. We'll have to do a deeper dive into that, but this works. So we'll just take it on faith for now until we figure out what's going on more. I think it's the best way to do that. Okay. Yeah, it's very strange. Other things we can do, there's more stuff on table 4.4. We can get the capacity, which is the maximum number of elements that are inserted into our vector without doing a reallocation. We can test to see if it's empty or not. It's a Boolean function. We can return the number of elements that are currently in the container, and then also the max size of the maximum number of elements that can be inserted into the container. Okay. So in looking at this stuff, so let's look at these examples that we have in the book here. So let's go to nano. Okay, so if you're struggling with your editor, then don't worry about that. Just go with this. So let's start with 4.5. Okay, and nano works kind of like emacs. It's based on emacs, but as you can see, all of the commands that you can use are all there along the bottom of the line. Okay, so which helps out a little bit. Okay. It also has, you can do a go to line or any of those things. Okay. Okay, so in this one, in this example, we're again including the IO stream, we're including the vector. Okay. As we go down, we're going to create a vector of ints. Again, it could be any type, but we're doing an int called int list. We're then going to go through and do a pushback on 13, then 75, then 28, and then 35. Okay. We're then going to just print them out using a regular loop. Okay. So in this case, we're going for I equals 0. As long as I is less than 4, doing I plus plus. Okay. Each time through, we're going to do the int list on that ith position. Okay. And then once we've done that, we're going to do it. This for loop here, we're going to take the same loop on the for, but this time we're going to take every element in I, or in int list. So int list of I, we're going to replace it with 2 times that. So that's going to double every element. That's all that's doing. Okay. And again, this is from the book. I find it sometimes useful. I like to see brackets, even if they're not absolutely necessary. And again, the tab will get you over there. That's really odd that it put it there, but it did. Okay, I'm not sure what that makes me think it's done something wrong. This was working until I messed with it. Now I'm just getting spaces everywhere. I don't know what this is doing. It's super weird. So we'll just forget that for now. But yeah, in general, I like to put in the brackets. Okay, but with no brackets, the for loop can only be 1 line. Okay, it's basically what that does. Okay. So we've just doubled things to show that you can iterate through and do whatever you want with them. Okay. Then it's showing here, again, using the normal for loop, just what those changes are. This is the same as the other one, listing the elements that are now doubled. Okay. We're then going to declare our iterator. So again, this is an iterator to a vector of ints, okay, called list it or list iterator. Okay. So we're then going to use that, and the same way that we used before, which is odd on the beginning and end, but we're going to do that. We're going to start, our initial condition is that the list it, so our iterator we're pointing to that beginning position, and then as long as it doesn't equal the ending position, we're going to go through and print out all of our items. Okay. The other thing we can do here, if we wanted, on the insertion, we can start, and again, we're going to now, that pointer is going to go all around. You can save it for something if you want, but in this case, we're going to set it back to the beginning. Okay, so at this line that's blinking there, the int, the list it, so list iterator points to the very first position, the value of the first position, that memory address. Okay, doing the plus plus 1 time, we'll move it to the second. Okay, plus plus again moves it to the third. Okay, so now that list it is pointing to the third element, okay, which would have the number 2, so 0, 1, 2. Okay, we can now do an insert at that position. So we're inserting at that third position an 88. Okay, so now we can go through again, print it out, and see that we've made that change. Okay, so let's take a look at this. And now this is all just acting weird. Oh, because I'm in nano. That's what my problem is. I'm not going to save this because it was working before, I'm pretty certain. So I can do a C++ on the example 4 or 5, and then do an a.out. And you see there's our original items, okay? And then we've doubled them in the next one. And then we printed them out again with the iterator, which is fine. And then we inserted the 88 in the 0, 1, 2, or the third position there. That's all we've done with that. Okay. So except for the strangeness of the of that ending, everything else looks okay, I assume. Other questions on that code? Okay. So there's a table 4.5 that has member functions that are common to all containers. That's a pretty big list of things that you can do with the beginning, with the ending. There's an R begin for reverse begin. There's an RN, which is reverse end. That's a pointer to the first element. It allows you to go backwards on things. You can insert, you can erase. Okay. You can do an assignment with the equals. You can test equality or any of the other things with the double equals, all that stuff. Okay. Then we have some member functions that are common to all the sequence containers, because again, we also have associative containers. That's insert, push back, pop back, erase, clear, resize, all that. Okay. So the last thing we're going to talk about today is this copy algorithm. Okay. So again, the algorithms, as you would expect, do things with the data structure. Okay. So the copy is going to allow us to do a deep copy. So we don't have to do that code ourselves, basically. Okay. So this copy function here, and they're going to do something a little bit strange in their example. We're not there. Let's talk about this. Okay, so the copy again is going to, there's like a from and a to kind of a deal. Okay, where you want to start from, where you want to go to. So we've got an example here on page 224. Okay, so let's type that one in. And let's do nano again. Okay, so I'm still including. Well, some of those are doing weird there. Okay. So in this case, if we have an int array, I'm in some weird mode. That's what it is. Something I was trying to do when I was trying to get that alt thing. It's acting very strangely. I don't know what to do about it, but hopefully it won't be an issue. Okay, so that's we can do an integer array. We use a copy to copy it to. Okay, so we've got 5, 6, 7, 8, and those need brackets. Okay, so this integer array here. Okay, yeah, it's that spacing is super weird. I'm not sure why. Something I've done. Well, I did the alt something. Alt greater than. What if that fixes it? Did I fix it? Nope, still weird. I don't know. No one's doing. Okay, let's go on with ourselves. Okay, so once we have this array, we can also create a vector here. And now we're still doing weird stuff, but maybe not. So we can do a vector of type int. Call it vec list. Want the size to be 4. So if we wanted to copy this, we could do the following. We would say copy int array is what we want to copy. Okay. And we want to copy this is the from. Remember, int array is the beginning memory position of this integer array. We want to copy, that's the from. The to is going to be int array plus 4. Okay, there are 4 elements. We're going to have to go over those 4. We want to get all that stuff. Okay, where do you want it to go to? Will be the beginning of our vector. We can do a vec list dot begin. Okay, and that's how the copy is going to work. That'll allow us to copy that over. Okay. You can also use the R begin and the R end if you wanted to copy it reverse. Okay, but that's the basic idea. Okay. So we're also going to go through this 4.6 example, but it uses this OStream iterator, which is a weird thing that we don't do very often, but you see it sometimes. And it's going to set up a way to put things to the screen using the keyword screen. The easiest way is to show you the example of that. Since this is acting weird, I'm going to go that. Okay, go to emacs. Maybe it's a nano thing. That's a problem. Okay. So it's this right here. It's this O-stream iterator of integer type screened, and by default, it's going to go to cout, and it's going to put a space between them. Okay. So all this is doing is we can send things to the variable screen, and it puts them on the screen. I mean, if that's confusing, you don't want to do it, it's not going to be something I would ever test you on. But that's what this example does, just to see what it's doing here. We can see it in this case. So here's our int array. Okay. And now we're creating our vector of the same size. Okay. And then when I do this, I'm just creating that screen. So now, in order to print things to the screen, I don't have to loop. That's the whole point, right? I can just copy it, use a copy function, because again, we have to include algorithm to use the copy. We're including vector, we're including iterator, and the item stream. Okay. When I copy, again, the from here is int array, the beginning position of our array. The end, since there are 9 items, is int array plus 9. Again, if int array is at position 100 in memory, it's going to go to 100 and whatever 9 times 4 is, 36, 136. Okay. If 9 times 4 is 36, my arithmetic is really bad. Is that right? I don't know. I have no idea. We won't stop for that. We won't mock my arithmetic skills. I do have a degree in math. Hey. Anyway, so that's just going to copy that directly to the screen. That's all that does. It's just a shorthand. You don't ever have to do that again if you don't want. Okay. Then we're going to copy again from int array to int array plus 9, again, get the whole thing. We're going to copy that now to the veclist.begin. Okay. So again, at this point, veclist until this line had no value. We declared it to have a size 9. So it has gathered together 9 different memory locations that it can do. That's what's there. Note, you can always add to it with a pushback if you want, or you can do a resize. Okay. So in this case, again, I'm going to use the copy from veclist begin to veclist end to screen. Okay, that's all we're doing there. Okay. And then this one, we're going to shift the list over to, okay, and copy what's left. So this is going to wipe out the last 2 values. So this is saying copy the R begin, which is the reverse begin, which is the end, plus 2 from there to the end. Okay, all that gets copied to the R begin. Okay, which I don't know why you would do that. It does weird things, but just to show that we can move things around. Okay, so when we compile this, you see that it displayed our first one here as an integer by copying it to the screen, just like a print, but there's no loop involved. I'm guessing that maybe, I don't know, it may be quicker or more efficient, but it may not be. Let's have to see. Okay. And then here we have the vector list, again, printed out the same way. And then this took that 5, 6 and moved it over and moved the rest of the things here, but it lopped off the last 2, the 29 and 75. Not sure why you would do that. Okay. But that's the idea there. Okay. So that's it for today. As far as that goes, we're going to talk a little bit more about the DQ starting tomorrow, a little bit more about iterators, hit that a little bit, read through that because we're not going to cover it in great detail. I don't think it's the most important thing. There's also a big example at the end of this chapter. Those big examples, you don't have to type them in necessarily unless the homework asks you to do it. It's on a grade report, but it's good just to see how they're thinking. It kind of goes through the whole thought process. Okay. And one thing that I will say is that if you're not already there in your programming life, we are certainly getting to the point where you can't just read the program, write the program, read the assignment, write the program, test it, and be done. Okay. Especially as we get into linked list and other structures, you have to be able to make pictures first. You have to have a concrete example that you have to be able to solve and know what memory is going to look like as we go along. We'll see that with linked list more. Okay. So make sure you're doing those kinds of things that you understand. If you can't solve a problem on paper, you can't write a program to solve it. I mean, it just makes sense. Okay. So what we're going to work on now is the first homework problem is programming exercise 3. So between now and 2, go and take a look at that. So that one's write a program that uses a vector object to store a set of real numbers. The program outputs the smallest, largest, and average of the numbers. When declaring the vector object, do not specify its size. Use pushback. Okay, so you're just going to, I mean, not too bad. We've done that before. You're basically going to input a bunch of numbers. It doesn't say that you have to allow the user to do it, so you can just do a bunch of pushback statements yourself. Okay, and you're going to determine the smallest of those, the largest of those, and the average by looping through. Okay, loop through however you want. Okay, but don't use an integer. Use just a vector for that. Okay. So I think in an hour you should have a pretty good jump on that. So if you have questions, make sure you let me know when we come back, or you can let me know beforehand. I'm not going anywhere, but we will get off of Zoom. Okay. Any questions about that?
I do have one question.
Okay.
Do you mind pulling up the code from that last example you wrote?
I can do it. Take me a second because I closed because I'm
I didn't realize I had my mic muted when I asked.
It's okay. It's my fault. Shouldn't have done that. Never log out until people are totally done asking questions. Okay, let me now share that. We go to the right directory. Find the right home keys. Yes.
Can you scroll down to the reverse array one more time?
Okay.
All right. Yeah, so I'm a bit confused on how it inserts the last 2 elements again, or the first 2.
Right. Okay. It's going to start. It's because it wraps around, which is all just weird. If you're at the end and go over 2, you've come back around to the beginning. You get the first 2.
Okay, so it's kind of modular in a sense with vectors rather than like a okay.
Exactly. It's a dumb piece of code. It's a forced example, but that's what it's doing.
Okay. Okay.
Okay.
This isn't a code related question, but I was looking at the syllabus and like the course schedule.
Yep.
What day is our final on? Is it 24th or 25th? The syllabus it says 24th, the schedule it says 25th.
I'm guessing it's the 25th. Is that a Friday?
Yeah.
I think that's the last day of class. It'll be the last day of class. I probably just got that wrong somewhere else, but yeah, it will be the last day of class. That should be a Friday, unless there's some weird holiday that June 25th is a day of celebration I'm unaware of. Okay, anything else?
No, that's it for me.
Okay. Did you want to talk some more, Christy, or are you happy? Or
I wanted to pull up what I'm doing here and have you walk me through exactly what I'm not doing right.
okay, I'm going to go ahead and stop the recording. Dylan, you can go ahead and go on and be working on the homework.